Continuation with maths. Wave functions. Wave functions, sine and cosine wave. If we take a graph with the angle on the x-axis in degrees against the sine of that angle on the y-axis, we produce a graph that changes positive and negative over the full 360 degrees. We can also express that in terms of this axis being time as well, and we'll be doing that for electrical rather than angles. Okay, so a sine of the angle 0 is 0, so a sine wave crosses at the 0 point on both the x and the y axes, and then the peak, a positive peak at 90 degrees, another 0 at 180, a negative peak at 270, back to 0 at 360. The cosine function has us starting with the cosine of 0 being 1, a 0 crossing at 90 degrees, a negative peak at 180, 0 crossing at 270, back up to a peak at 360. So the sine and cosine functions are pi over 2 radians, or 90 degrees, out of phase with each other. Yep, that's what they are. They're 90 degrees out of phase with each other. What you would say electrically is the cosine function leads, because it peaks sooner than the sine function. Science and electrical. So both waveforms repeat every 360 degrees. All clear so far? Now, major function in this session. Let's take a look at some of the terms involved. Try and make that a little bit bigger, clearer. So, like I said, talk about the angle going round in a anti-clockwise. Alright, and we can gravitational speed, or we got this function y equals sine p. Angle to this height here. Angular velocity also equal to 2 pi f p, which is the length of for a sine function where the A in front here is the amplitude, is the height of the peak, times the sine of omega, which is the angular velocity in radians per second, t is time in seconds, and then the plus or minus alpha there's a standard. Oh well. So if we've got and a second one, you need that phase angle, and you're expressing the difference in phase angle two waves or two waves. Yeah, if you've got one, you've got no for a phase shift. It's assume it's if you've got two, then for instance to add them together, you need to consider that they're gone. All right. You always pick one function, usually, to have a zero phase angle, and then all the others relative to that one. So, amplitude. So if we look at what I've graphed there, in front of the sine function. So the first one is amplitude 1. The function is just sine t. The second one has amplitude 2. That's 2 sine. And the third amplitude 3 sine t. Frequency one cycle full frequency per second. And then this one, we're starting with the base function of 2 sine t. One has a 4 radians. Over 4 radians. The red one. And the phase angle between these two, which is 90 degrees. if we were looking at the difference between those two, the 90 one's plus pi over 4, one's 4. Part into of the sine rise. F pi in units of each things that are sine wave. Your sockets over there as of 100. Once you've done enough of these, then you just know that 100 pi is 50 hertz, 120 pi, right? Sometimes you want it in omega form, sometimes you want it in frequency form, all right? Questions asking for that decides for you. Right. Alternating current is given by I is equal to 30 sine 100 pi t plus 0.27 amperes. Find the amplitude, periodic time, frequency, and the phase angle in degrees and minutes. Good. Come straight question, straight from the time. Probably better. Bit in front of T. Therefore, two pi equals 50. Yep. How do we find the period? Time in 1 second. How do we find how long it takes to do one rotation? Frequency. And 50 times. Yeah. All we want is how many seconds is one rotation. Period. Yeah. Going to go 50 in 1 second, so it's going to take 50. Seconds. Turn that up the other way. Same thing. Pi of 100. Yeah. Phase angle. To you as in the stand right. How do we get that to degrees from earlier? Sure. Electrical, you'd say. All right. Have a go at the next one. Oscillating mechanism has a maximum. What do we think we're going to do that one? We got a 5 here is I, omega, and alpha. So that we can write, that's what we're, and we put that into displacement equals Which bit can we get right quick? Omega is equal to 2 pi f, which is 2 pi times 60 equals 120 pi radians per second. Yep. Anything else? What? At time 0, displacement is 90 centimeters. That's the trickiest bit, because that's the bit that's going to help you find the phase angle. What else can we find really easily? Yep. Maximum displacement is equal to the amplitude. Or we should say it the other way round. Amplitude must write slower on board. I is equal to the maximum displacement which is equal to 2.5 meters. Now, this other bit, probably really best if we sketch what this oscillating machine is doing over time. So there's our axis, okay, and it says that it's starting at plus 90, so we know there's going to be a peak here, 2.5 meters, but it's starting at 0.9. With that displacement D on that scale. Yeah, and we're looking at what as far as the alpha is concerned, we want to know what the difference is between that sine wave and one that would start at 0. So we're looking at that angle in there. Yep. How can we find that? What bits of our function have we got so far? We're looking for a function that says we're going to find D. Do we know I at this point? Yes, we do. 2.5 meters. Yeah. That's times the sine. We know omega, 120 pi. T, and then that's plus or minus alpha. So we know everything now except alpha, and we're being given what D is. D equals 90, or 0.9 I should say, centimetres, got to be careful, when t is equal to 0. So what we can do is say this, 0.9 is equal to 2.5 sine, and that, when t is nothing, that'll be 0 on the, yeah, plus alpha. I'll just put it in there for completeness to show nothing, because t's nothing. When you get the answer, we'll know whether that's positive or negative. Alright? So that bit in there is alpha. We've got to rearrange that now. What are we going to do? Bring the alpha bit over this side. Yeah. Is equal to 0.9 over 2.5. Yeah. Therefore, alpha is equal to sine to the minus 1 of 0.9 over 2.5. We want our answer in radians, remember, because we got omega question. So you need your calculators in radians mode. Yep. So our full function, therefore, displacement equal to 2.5, the amplitude, sine 120 pi t plus 0.368 radians. It's an expression for that oscillating machine, and its position at any point in time can be determined by that. Yeah, if I wrote a function of that in some graphing software, that would show that movement over time. Okay. And is positive angle what we would expect? Remember, we're looking at, does it peak before or after something that's got a 0 angle, and it peaks the red one, which is our oscillating machine, peaks before one with no angle. So a positive radians is correct. Yep. Okay. Right. What we got on the next page? Instantaneous value of voltage in an AC t seconds is given V, instantaneous values, lowercase letters. Okay, is equal to 340 volts sine 50 pi t minus 0.541 volts. Determine the amplitude, periodic time, frequency, and phase angle in degrees, which is actually what we've done in the previous question. So do that bit. If you're done and want to start having a go at the other bits, please do so, but they require some rearrangement and pulling around of the formula that you might not be able to do yet.